you.
Thank you very much. Thank you, everyone, for coming here today. I'm Pablo from Nokia. I'm kind of responsible of leading the scientific vision of our extended reality lab in Madrid, in Spain. So what do we do in the XR lab? Basically, we are a research team. We are trying to research the future of human communications in Nokia, which is, of course, this one. No, it is not. But this is where we come from, and we are quite proud of that. We want to understand how the communication between people is going to be in the future, and we have kind of a vision for that. And in the lab, we do a mixture. We have a mixture of researchers of mainly three intersecting technological fields. So we interact between XR technology, AI technology, and telecommunication, 5G, 6G technology. And the approach to do that together is putting the person in the center. So we try to create end-to-end solutions and to research on how they work so that we can solve actual problems for the people, basically. We understand how technology works together to make a brighter world, to improve the life of the people, right? To shape this vision into something a bit more tangible, we have coined the term real-verse to try to understand ourselves, the kind of research that we are doing, and try to put ourselves more or less in the map so that it's easier to understand what we are talking about and what is shaping our research, which is guiding what we try to do, right? And so to explain that, we all know the concept of metaverse, of virtual worlds. We have been discussing all this. So this is like the picture on the left. This is like a typical kind of use case, let's say, or example where you may have like you're playing cards with some other people. You know, we might be in different places, are they represented by the avatars, right? And somehow this feels real because it tricks your mind, right? This is how VR works, right? So it tricks your mind in three different ways. In the sense of being there, when it's called a spatial presence, so basically in the sense that you feel that you are in this virtual world. In the sense of being with somebody else, so you have this social presence, you are together with other avatars that you feel like other real people. And in the sense of embodiment, you really feel that this avatar that you are embodying, it's actually your body and you control it, right? So this is a way that it is very powerful because it mimics the same mental process that it happens if you have, you know, the old way of doing this in real life, like, you know, this simply going to the bar and play cards like our elders do in the villages, right? So what we try to do with the real-verse is not creating a new experience like the one in the left, but basically transmitting the reality like the one in the right, so that you feel that technology is not there, and you're able to communicate, to teleport, you know, and to play cards, ideally with somebody in a different place in the world, just as if you were there. So this is what we call the real-verse. So the whole idea is that, again, you have two people in different places in the world, and they can visit each other or maybe visit a third place in the world and feel and act as much as possible if they are together. So this is our goal. The goal is being transparent, is that all the technology, all the network, everything feels like if it's not there, and you really can be as teleported to somewhere else in the world to visit another place or another person, right? So this is where we aim to go. And of course, this is a tremendous challenge. It's actually impossible in practice, right? But it's a good goal to go and to understand and to analyze, right? We think it's a very interesting way of thinking. And we think about it, and we believe that to achieve this goal or to go towards this goal, your technology has to provide at least 4 different functions, right? That we have in the real personal communication. So the first is like the obvious one, the face-to-face communication, right? The being able to face the other person, to have this visual communication. I see you, I'm able to talk to you. It's not the same having you here as presenting this presentation from home, right? We know this is different. But there are more things rather than this obvious one. The second one is the shared immersion, so the ability to meet together in the same space, that if I look here and you look here, you are looking at the same object or the same space, right? It's not only face-to-face, it's more about sharing the spatial understanding of what's happening around us. And this happens, for instance, in the metaverse or in the virtual worlds, right? But there's a third thing, which is what we call the shoulder-to-shoulder communication. So it's basically, it's not that we are together, it's that I'm able to visit you, right? So it's that I'm able to teleport to your place because your place is important. So it's not that we meet in the metaverse, it's that maybe somebody else is able to come to this particular room and visit us and talk to us, right? So this is a third feature. And the fourth feature that technology needs to address is putting our own body into this experience. So being able to interact with our own hands, with our own body, so place ourselves like in the middle of the experience. So these are like the core technology lines, and there's a small paper over there if you want to have a look at it, because it's very difficult. It's not so difficult to address one or two of them, but it's very difficult to make them work all together for a number of reasons, right? I'm not going to be too much into detail. But there's something about that, right? So when we try to, and there's like a 5 pillar that I want to talk about before going into how to approach that. And the 5th one is, we've seen, so the problem with the XR technology, let's say, is that in a way, it is somehow possible to solve all these issues, maybe not all together at the same time, but we have enough technology to really create very powerful and interesting experiences. But still, even though, as we said on Monday, the XR is now becoming mainstream, but it still is not mainstream in the same way as our cell phones are, for instance, right? And somehow it is because it's a bit difficult to go beyond the niche applications or the wow effect, right? And we have, in particular in research, that's important because we have found us several times in the situations where we developed a prototype. We have people testing the prototype, even for like practical use cases, and then they told us, okay, we like the prototype, but we are not going to use it, right? It's very complex for our daily work, right? So maybe we are requesting people to adapt too much, right? So we have another way of thinking to add to this risk, to this sauce, to this meal, right? Which is, we really need to make sure that from the very beginning, even if the technology is not totally ready, even if we are like taking shortcuts to make things work, we need to think really, really hard about the user, about how to make technology which is useful, easy for everyone, right? So this is the vision that we have called the Incluverse. We need to make the technology inclusive from the very beginning, so that we try to find the usage problems as soon as possible, so that we are able to somehow overcome them in the very beginning, right? So I will use an example of a particular project that we are finishing now, which is that we have tested our technology with people with intellectual disabilities to try not to develop adapted technology for people with ID, but to use them as the testers of a technology that aims to be targeted to general purpose population, right? So we need to really understand if we are able to adapt technology to people who have more difficulties into adapting to ourselves to make it work. And I will put a short video now. It's in Spanish, but there's some dubbing, and you will see the visuals, because it shows a bit, it summarizes a bit the research of our group and where we are.
Allá vamos. Hola Raquel, ¿me oyes?
Hola, sí.
Dentro de la Fundación Juan 23 se venía ofreciendo un curso reglado, cocina y repostería. El problema surge cuando algunos alumnos no pueden acudir a las clases. Entonces es donde entramos en Incluverso 5G y, haciendo uso de la tecnología de realidad extendida, permitimos que de forma inmersiva los alumnos puedan seguir las clases en todas sus fases, utilizando la tecnología de telepresencia de Nokia, el BU.
Cuando por primera vez me plantearon la posibilidad de realizar una teleformación de algo como es la pastelería, que es algo muy práctico, he de reconocer que fui escéptica, porque no sabía muy bien si iba a ser posible un aprendizaje real Y la verdad que el trabajo de estos meses me ha demostrado que es perfectamente factible y que la realidad es que hemos llegado a elaborar una receta.
Me ha gustado muchísimo colaborar con el curso. Sara me ha ayudado muchísimo y bueno, pues que estoy muy contenta y muy ilusionada.
So, how does our approach like? So, how are we approaching this huge problem of the real verse together with our users, right? So, we have a problem to solve, right? So, we want to have, so we have Sarah, who's a teacher of the cooking course. It's a professional training course. And we have Raquel, who cannot attend the class. So, she wants to have the training at home, right? So we put a device at Raquel's home, and Sarah is able to put a headset and connect. And we have this device has some 360 video. I'll have a slide after that about it afterwards. And then Sarah is able to feel and see spatially as she was really presented at Raquel's kitchen, so she can talk to her, and she can teach, and she can interact, right? So this is one of the key technology pieces that we are researching on. The other one is that we want Sarah to have her own body inside the experience, because she needs to gesticulate, she needs to manipulate objects while she's teaching, right? So we want her body not as a virtual avatar, but actually as her own body in real time, as pass-through video, to be put into the interaction, and this is what we call video-based self-avatar, and to interact naturally with the environment, right? And of course, this, which is a bit asymmetrical situation, it needs to be also happening the other way around, right? So it's also Raquel, the student, who needs to be able to teleport to the kitchen and be able to manipulate and do the recipe at the same time as the teacher, right? So as I said before, we have basically doing research for a number of years in a number of technologies, but it's grouped around two main technological assets. This is our main prototype. This is especially for testing the use case and the possibilities of the technology. It's what we call Snow. It's the third iteration in terms of hardware of something that we have been working on for the last 5-6 years. And technologically, it's not very sophisticated. It's just a 360 video camera transmitting video in real time with enough bandwidth and low latency so that you can have bidirectional conversation, and there's also an avatar representation of the remote person for the local. So basically, you can be around the table, and in this case, Lucia is connecting to this table and is being able to talk and chat with the other people as if she was there. And it has the sensation for the person who's remote is really natural. It's really nice, let's say. So the interaction is very, very good. The possibility of looking around creates a lot of possibilities, very interesting for remote support, for understanding the space. And it also has lots of problems that we are trying to solve and research. Right? So it's also a very nice tool to understand the difficulties of hybrid, immersive hybrid interaction situations, right? Where the real world is important, which creates a ton of totally different problems, right? We have a second research line, which is what we call video-based self-avatars, which is basically like our starting point to really understand the local space and trying to build this blended reality between the remote and the local. So basically, in this case, the idea is that we capture the video through a camera basically plugged, because now we have the cameras in the HMDs, but when we started, it didn't happen, so we had to plug the camera in front of the HMD. And we capture the world through this camera, and we have an algorithm of semantic segmentation. Basically, from the pictures that I see from this camera, I'm able to segment out only my own body, so I'm able to put my body into the scene, and then, I have not a virtual avatar, but my body in real time used as avatar in this scene. Right? Again, it's very interesting, it's very powerful, it's very problematic as well, so it also creates a lot of research opportunities, right? So there's also, it's also a research line that's been taking years, literally, from the first iterations, and then, we got this first algorithm for like 4 years ago, and then we are now working on making 3D and adding other objects besides your body, so you are able to bring some relevant objects, selected objects to the virtual world with you at any time in real time. Right? So these are like the two main research lines that we are, and you have seen them more or less in the video, right? And this is where, as far as we have come, right? So what's next, and where we see that the artificial intelligence can really help into breaking the remaining barriers that we have to have a realistic human communication, right? So we envision that there are three main barriers that we are also researching on, but for which we don't have solid results yet. But I want to kind of hopefully inspire you and ideally, shape what we think that is missing in the research in that area. The first one is the emotional situation, right? The mediated communication, anything which happens through HMDs, really creates some barriers to the empathy that you are able to communicate, right? So we need to somehow overcome this one. The second is the spatial one, of course. Again, you have seen that there are lots of problems in trying to really blend the physical space of different locations around the world, right? So distant communication made things more difficult. We are going towards teleporting, let's say, but we will never be able to really be totally us if we had been able to do like a physical teleportation to a different place. And the third one is temporal. Why? So in this world, well, basically you can be in different time zones or have different schedules. So how can you synchronize the communication where you might not be available at the same time in both places, but still you want to communicate, right? So this is what we call the best framework. So how can we have the best communication if we break these emotional, spatial, and temporal barriers, right? So let's have a look at the challenges for that. I think we have some time. So a bit quickly, right? So emotions, how does empathy work? This is not our work. This is basically basic psychology. The whole thing of empathic communication is that I have some emotional state that I'm able to code in my voice, in my gestures, and then you, on the other side, resonate on that. You have your empathy that you receive those signals and you adapt your own behavior and your emotions to that, and then you transmit it back to me. And there's like this continuous loop of empathy that flows in normal face-to-face communication, right? But what happens if this communication is not face-to-face? If we have like technological barriers to reduce the ability for us to communicate, or maybe that we have our own barriers about that, right? We are working with people with intellectual disability or with autism where there are some limitations. I mean, we all have some limitations always on that, right? So how can we use technology to enhance our empathy, right? And this is a very interesting problem because it's very challenging for a lot of reasons, right? So summarizing, it really requires that you are able to use technology, first of all, to better understand your own emotions. So this is like what we call the basic emotional regulation loop. So being able to measure yourselves and understand your own feelings better, being able to communicate it better so that you can kind of adapt to the other person at the same time. And of course, you need to somehow add a break. So we need somehow to add, you need to have some agency on the emotion that you want to communicate, right? Because we don't want the technology to steal your privacy, right? So you really need to be in charge of how does it work, right? So this is something that we have only scratched the surface in terms of research, but it's a huge problem for a number of reasons. So it's one of the hard problems that are out there for the research. So from the technical perspective, basically because it's the worst use case for any AI situation, because it's very personalized and it's very noisy. So it's very difficult to map your own so how your body reacts to emotions is different from how the other person's body will react. So it's very, very personalized, and it's very difficult to get data, to train algorithms, and to understand what's happening, and to be able to predict and help things in real time outside the lab, right? It works in lab scenarios, it works in medical situations, but it's very, very difficult to make it work in the wild. And of course, it doesn't help, but it's a very complex problem in terms of ethics and legal situation. It's probably the worst case, right? So we have, you need per person data, and you have the mixture of sensitive personal data and high-risk application according to AI Act. So it's basically kind of, a nightmare situation. But still, we believe, a very powerful and interesting problem to address. So kind of using the technology to enhance our emotional intelligence is probably something that would help the world a lot if we manage to do it in the right and ethical way, right? So second one, a bit more obvious from this community, let's say, is the spatial barrier, right? So how can we make that the teacher and the student are together in a physical space which looks consistent for both of them? Right? What we have now in the use case, what you have seen in the video, is that we mix two different views, right? So we have the augmented reality view that you are seeing there, where the student is able to see her table to cook. She's able to manipulate the ingredients in real time with the HMD on, and she's actually doing the recipe with the HMD on, and she sees like a big floating screen with the teacher, so she's able to understand what's happening out there, right? So, and we have the other situation, which is the augmented virtuality, where the student is immersed on the 360-degree video of the kitchen. So she's totally teleported to the kitchen and is still able to see her own body, hands, and stuff like that. But we would really need to go to something which is consistently in the middle, right? So there's the right part of my kitchen and the right part of the other kitchen out there. OK, I'm running out of time, so I will be very quick. And this is a very tricky things. We've done things which we have started with very, basic technology. The most promising technology for that, you've seen over there, you've probably heard about that, is Gaussian splatting. Still not usable in real time, and still with a lot of problems, but it appeared 2 years ago, and it's where we think the future should be, right? And very, very quickly, because I'm running out of time, what happens if I cannot be at the same time as the other person, right? OK, this problem was solved in Harry Potter, right? So when you send in Harry Potter, when you see a picture, when you send a postcard or whatever, it's not static, right? It has some memories inside. So it's not the other person, but it has some memories, some knowledge, some personality, and some intention inside. So how can we replicate that with technology? Our idea here, our prototype here is, OK, let's replace the real teacher in this teleport situation with a virtual one, right? But not with a virtual one in terms of a purely virtual avatar, right? But basically, let's make the teacher be able to record the lesson and have like a kind of, I can prepare a bit the tutorial part, right? So it's like I will send you a message with instructions, but with some additional intelligence so that you can interact with the instructions, right? Basically. And you can ask me later about the details because it's very complex. But basically, it has a lot of challenges, and we love challenges, right? So basically, of course, we need to solve how to make the conversational flow natural. If you talk with avatars, still this is not a solution. It's totally solved yet, right? We need to have a strong backend, so we need to really be able to correctly encode the teacher intent. So the teacher, how I want to transmit this message, I need to incorporate the teacher's knowledge to be able to answer the questions. And we need to have a good teacher representation which somehow encodes the basic personality traits, the teacher voice and stuff in a way which is familiar to the other person, but still distinct, right? So we know it's a message from the teacher, but we know it's not the teacher in real time, right? So also, again, the trust problem and the ethical problem out there is very, very complex. So sorry for running. I always put a lot of material in my slides, and it always happens to all the time. But I hope I've been able to show a bit of the challenges that we are researching, but not only that we are researching, but basically how we envision that there are very powerful research opportunities to really improve human communication, right? And my final message is that this metaverse or immersive world is something that we are building together between all the community who's here these days, right? So we need to stop a bit and think how do we envision the future of the immersive communication and what we want to contribute there and what we want our role to be in this future world. So that's all. Thank you very much. Mm-hmm.